Saw a number of you over at the pie wall. Remember, if you got any dietary restrictions, food allergies, even if it's just texture stuff, let me know. Like if you just don't pie because it's gooey, that's what the cookie pie and the pumpkin pie were specifically made for, is the texture eater in the family. She always makes sure to have a couple of gluten-free. But was it last year? I had a kid who could not do gluten, eggs, or milk, which basically eliminates all of baking. She still made it happen. Okay. Wait, is Bridger in debate too? No, just gone. Okay. I'm just happy that you're not wasting it anymore. Now what you do is you crumble them up like that after toasting them, and then throw them in milk and use it as cereal. Sorry, Sammy, you're no longer on the good list in this room. In high school, I used to take down a gallon a day.
I can't handle the texture. I know that it's like water, but like still.
No, it's not. The texture is different.
I'm scared that my water is gonna turn over milk in my pen. That's a real fear. That is a genuine fear. I know.
Please make sure to do a decent scale on this. Don't just BS the graph and label points off to the side. Like if your extrema are at really goofy high or low values, have a scale that matches so you can see them.
Next period,
Mm-hmm.
I'm gonna go to that class for a little bit and do my homework in there and then come down here if that's okay.
Yeah. Okay. Looks like most of us are either done or we're finishing up those extrema. We got everything else taken care of. 2, 3, 4, 5, 6. Okay. If I look at just my A and B terms of all of the polynomials, I know that I'm going to have a negative even polynomial, which tells me we're going to start down at negative infinity, end over at negative infinity. In between there, my zeros are 0, it happens twice, acts like a parabola. 3 happens once, acts like a line. And negative 2 happens thrice, so it's going to act like a cubic. So we'll mark those. U and U and U. So the general shape of it, oh, also if 0 is the x-intercept, it's also my y-intercept. The general shape of this is it's going to start down here and it's going to bend through negative 2. It's going to bounce off of 0 and then go through 3. Now that's the general shape of it. The question is, those two maximums, the relative and absolute, how high are they going to go? I do know that the positive side one is going to be much larger than the negative side one because those zeros are further apart. So the distance from the x-axis will proportionally be bigger. After that, it's go to my calculatron and start plugging maximums. You know what? Y'all press the buttons. Let's save some time here. The relative maximum. Let's see if we can have a consensus. The relative maximum, this guy. What we got? Yay or nay? Okay. Collectively, the village says yes. The absolute maximum, I'm betting that one's a lot bigger. Like, what, a couple hundred? Okay, so let's read off the whole thing. Survey says? Okay. So, again, I know it's this general shape, but now if I know that I need to go up to 590 at least to fit my maximum, I have 10 boxes. You could have done whatever you wanted. You could have taped multiple sheets of graph paper together and just done it by ones. I've seen a kid do it. Just to prove a point. I'm going to say go by 60s because I got 10 boxes going north. So that's what I'm going to do. Green? Yeah, green? Yeah. So I'm going to say go by 60s, which means we're at 8 point something. So these are going to be very, very tiny. Like, meh. I know that's like 30 on the scale, but I can't make it any smaller than that. And 2 point something 590 is going to be right about meh. Now, with how fast those take off, I'm betting, check your table, go back to x is negative 3. I'm betting that's still past the map, or very close. X is negative 3 goes how far down? Negative 108? Oh, okay. Never mind. I can do that. What about negative 4? That's probably off. Okay. So we're going to come up, bend through here, barely move off the axis, bounce up. Before I come up to this maximum, I got some points in there. Where are we at x's 1 and 2? 1 was 108? Okay, so and 2 was 512. So there's 600, there's 540, there's okay. Just so I can make sure. And then so I'm looking for a couple of things on your graph. Do you have the correct general shape? Like you actually have a negative quartic with two maximums on it. One relative, one absolute. 2, I want to see, do you actually have the behavior at those zeros, because that's what we were talking about. Did you try to put a little wiggle, a little cubic wiggle at -2? I have to say a wiggle because if you describe it any other way in South Dakota, you're indoctrinating. And do you have your 2 extrema points labeled? And then I'm going to leave one floating for, oh, whoopsie. I'm talking like, oh crap, I missed the negative in front of the 2 at the beginning. Or, look, I did all that stuff and I did it perfectly. I missed the cubed on x plus 2. So I'm gonna leave that one for, look, I did all that stuff, but facepalm. Okay? Yes, it is. So, y'all good? Okay. You know, y'all miss out because of inflation too. This is a year, yeah, it was about a year ago. A little less. That we had to stop doing Donut Fridays. I did for 7 years. Every Friday we used to just line the counter with donuts. I had a standing order at Safeway. They upped the prices. Every Friday it used to be $5 for a dozen. So I just load up the counter and kids would come in from all over the school. Maybe some of you did it. And then they upped the price now, so it's $9 a dozen, no matter what, any day. And it's just not worth my time. So it was a bummer. Like the guy who used to work the bakery, the old manager there, Steven, he used to have fun with it too. Like he would put different candy and sprinkles and decorations and crap on them for different holidays, and around Halloween he'd put the eyeball chocolate in the middle and then like gummy worms on it, and just, oh, he had fun with it. The cereal ones, anyone likes the cereal ones where it's like it's got the glaze on there but then it's like Cocoa Puffs or something? Yeah, he had fun with it, but bummer. The homework, there were 2 can you graph it, and after what we just did I assume that was fine. One of, can you do the spaghetti monster? I know we were almost done with that, but most of you said that you were good with the power regression stuff we were doing. So it's just a matter of, can you put everything in one spot and choose the appropriate one? So this one, how many of you actually did it? Okay. So I'll walk you through because I already got the data in here. Okay, so follow the bouncing ball, and then we're going to practice it again. Stage one. If I have data, I want to throw it in my table. I put stuff in my table how? Okay, so I stat, I edit, I put all that stuff into, in my case, I have it in list 1 and list 2. If I want to see my scatter plot, how? Second, stat plot. I'm gonna turn the plot on. I'll make sure it's the list that I want. And then how do I go to that one? Because right now, I'm on my standard 10 by 10 graph. How do I go to my data? Okay, zoom. And if my stat plot is on, this only works if my stat plot's on, I can zoom to my stats, 9, and it shows me what the bejesus is this. It just looks like birdshot, right? Now, I'm going to start trying different models and looking for two things. A, how realistic is it as we extend past? That's extrapolation. And B, how good of a fit is it inside the data? That's interpolation. Before I do that, I need to know how good of a fit my models are going to be. So, assuming that someone has reset this calculator, I need to check that. Turn those stat diagnostics on. If you're on a newer calculator, it will be under mode. If you're on an older one, it'll be in the catalog. Okay. One more. There we go. So I turn stat diagnostics on, and then stat. Calculate whichever regression you want. We're dealing with linear, quadratic, cubic, and quartic. And we'll store them into Y1, 2, and 3, and 4. So rapid fire here for alpha trace, throw it in 1, poke the thing, write it down. This should go faster, but we're streaming, so. Whoa, you mum. Shut your mouth. No one in here understands that reference. Alpha trace, Y1. There we go. Okay, check out the fit on that one, though. 36.7% fit. Okay, y'all, that would be like me strolling down an aisle in Walmart wearing a Speedo. Thanks. Okay, no one wants to see that, right? No one wants to see that. I don't want to see that. 37% fit? Are you kidding? So, stat, calculate. I'll go find a quadratic, see if that's any better. We'll put it in Y2. And again, you should be writing all these down as you're going through them. 57% fit. Okay, now I've upgraded from a Speedo to booty shorts and a crop top. Okay, still not what you want to see. Stat, calculate. We're going to go to a cubic. I make all these references, by the way, because I know that weather is about to change, and boy, when weather changes in the Midwest, you start seeing a whole lot of stuff. Go to Y3 cubic. 61% fit, still not the greatest. Like, none of these are very good. So we're throwing all our hope behind that quartic. We cross our fingers. We say, please, oh, please. Come on. Come on. 79. So none of these are very good. But then check out the graph. and just physically watch which one seems to fit the trend better. You see why those two are like not even close. The cubic, it tries. Okay, it's like the gif of like Bart Simpson with the "at least you tried" cake and then throws it in the garbage. Okay, and that Cordic, like, it's trying its best, but you see why none of them were really a really good fit. So at that point, you need to decide by the context of the problem, what's going to be the best. We're talking about the number of feet below the maximum water level of a reservoir. So how many feet below maximum, the top of the reservoir? You ever seen the Pactola when they open it up? Because they haven't had to do that for a few years because of a drought, but when they open up Pactola and just let it gush down the canyon there, that was probably, what, 5 years ago, 6, that they really had to open it up. So how many feet below the maximum it is? They're talking about months. Does it make sense to go past the 12 months? Like reading the problem during 2007. It doesn't make too much sense to go past 12 months if I'm just talking about 2007. So in that case, I'm going to use the Cordic because it has the best fit of the 4 models. If it's inside my data, I'm picking whatever's got the best correlation coefficient. But if it goes past my data, extrapolation, then I got to start thinking. Then I have to pay attention to what has the best context for the problem. Okay? So that is where we left off. I want to see if we can do it. You and you. Okay. I know we didn't quite finish this off. I don't want to go back and throw everything in your calculator now, but you get the idea of if you got the line, and then you got the quadratic, and then you got the cubic. No, that's a Cordic. Cubic. If you get all of these, you pick the model based off what I just said. Interpolation or extrapolation depends what your question is. Write the polynomial that you choose. Gotcha. Use the model to estimate percent savings in 93. Is that inside my data or outside? So I would use the Cordic because it's inside my data. So I would just go to the Cordic model and then plug in 1993. Y'all remember how to do that from the power regression stuff? You can either trace it on the screen. You could plug, I think we did years since 1970. So I would plug in 23 for X. I could do that tracing the screen. I could do that on the table. I could manually plug it in, whatever your jam is. Use the model to determine the approximate year in which the percent savings reached 6.5%. Now they're asking a y. Do you remember how we took care of I'm asking a y, find x? We go find the line. I would put 6.5 and then I would, whatever model I want, I would go calculate the intersection. Okay? Now again, that depends on which model you chose. Next to each one of these, and what I would like you to write next to this is explain your reasoning. When you choose a model, tell me why. Okay? Because if you have a reasonable, logical explanation for why you chose that model, even if it ain't close to what I was looking at, I'm still going to give you credit for the process. Okay? So, all that's where we left off. Let's see if we can do it. You don't have to put the scatter plot over here, but I would like you to put this stuff into your lists. Make your spaghetti monster. We're going to do linear, quadratic, cubic, quartic, and then we're going to choose which model is the best to answer these questions. Also, before everyone gets started, so that we're in the same ballpark here, I see time as my x value again. What should we change it to so we're not putting in gigantic numbers? Okay. Oh, it even says that. It says do years since 1900. But, okay, that's in the directions here, but make sure that you always put that next to your table before you start typing. Years since 1900. Well, I'm putting in 0 through 180 now, instead of 1,900 through 2,080. It just means that my y-intercept is going to start back at 0, or instead of, or sorry, it's going to start at 1900 instead of at 0. So get your data in your lists, and let's see what we got. Clear this out. If you impatiently just reset the calculator before doing this, remember to turn your stat diagnostics back on. Yeah. I'm glad most of you went and grabbed the color calculators, because again, I got the final result up there. Boy, if I was in black and white and my pixels were bigger, would that just look like a gross. You ever seen an old LCD screen when someone just hits it and the crystals inside break? Okay, maybe bust your watch or something. You can still see what's going on though, right?
Yeah.
Okay. It ain't pretty, but okay. No, I just want to make it easier. If you have no problem with it, go for it. Okay. Remember, there is a graphing calculator emulator on your laptop. It's not good. It just call it what it is. It is the TI-83, the same one that I used in high school. And the same one we kind of ribbed Sammy about, the old hand-me-down. It works. It's just you're going to have to do a lot more parenthesis work. Instead of getting that pop-up menu, you're going to have to type list1, comma, list2, comma, y1 before hitting your regression. The screen's pretty pixelated. I personally just don't like that emulator because you can't resize the window. It is however big it is. What are you trying to do?
Okay, so when we're trying to find the estimate median range, do we plug?
No, this.
Yeah.
Dude, it is the median age.
Yeah.
Estimate the median age, the Y value, in 2005.
Oh, so it's just those.
Just plug 2005 into your chosen model. Which model are you choosing?
Would it be 105 since it's because 2005?
Oh, yeah.
Choose 105.
Yep. Just completely blanked on what was happening there. Yes. Yes, ma'am.
How do I know which one is better?
Well,
Median ages.
you're asking for the median age in 2005. Is that inside or outside your data set?
Inside.
So use the one that has the best fit.
Okay, so it doesn't like. Okay.
So I would use my Cordic to answer that question. Now, our calculators only go up to Cordic for the polynomial regression. And we saw this yesterday where you get that law of diminishing returns. The higher degree you go, that leading coefficient kept getting smaller and smaller and smaller, meaning it had less impact. There is something called, maybe you saw it in Algebra 1 or Algebra 2. There's something called the n+1 point principle that says if you have a data table with 5 points in it, there's a Cordic that fits it perfectly. If you have a data table with 4 points in it, there's a cubic that fits it perfectly. If you have a data table with 3 points, there's a quadratic that fits it perfectly. The n+1 point principle does exist, but after Cordic, it just becomes so messy and the coefficients get so tiny that it's not worth it. Okay, you're talking about the fit of the function. It's kind of like the difference between your older siblings' hand-me-down clothes versus you get to buy your own clothes. That's the difference between a linear and a Cordic. The difference between a Cordic and like a degree 9 is whether you paid $24 for your jeans at Walmart versus your friend paid $130 at some outlet store. It doesn't fit any better. Okay, so I got the spaghetti monster here. Did you get to the spaghetti monster? You got your models written down. Those models, what was the correlation coefficient on them? They were all really good, weren't they? They were all 97+%. And that's why they're all clustered together like this. They're all a really good fit to choose. So it depends on my question as to which model I'm going to choose. So the first thing they ask is, estimate the median age of the population in 2005. Is 2005 inside this data set?
No. Well, yes, but
From 1900 to 2080? Yeah, it's inside my data set. So I'm going to choose whichever one has the best fit. Now watch what happens when I say trace. Remember, I can arrow up and down between the two different functions. You can also do this in the table. I'll show you that in a minute. Okay, first I'm going to get down on one of the equations so that it doesn't quit on me. And I'm going to say at 105, because that's 2005. The line says the median age was about 36. The quadratic says about 36. The cubic says closer to 37. And the quartic says about 36. They're all 36 to 37, aren't they? So I would just say about 36. Because it's inside my data set, I'm going to pick the model that fits the best. In this case, it's a quartic. And I'll use that to answer my question. Additionally, the next one is what? Estimate in what year did the median age reach 30? So y equals. I'll come all the way down here to, never thought you'd put this many things into one graph, did you? Well, some of you. We did this in Algebra 2 last year, or last semester. It was, average age was 30, or median age was 30. So again, it depends which model you used. If I calculate the intersection, calculate intersection, you just pay attention to which model you're looking at when they say first curve, second curve. I'm going to say we chose the quartic, so that'll be first curve. Second curve is going to be my y equals 5, or y equals 30 line. Guess, I don't care, tell me the answer. Come on, come on. And then translate back into what is that as a year? 1964. Okay. Now, here's why we have to be able to choose. Now, in this case, my data is already extrapolated out past the current year. Come on, Frank. Frank. Why are you so... I'm hitting it 3 times. Why are you going back to the top? But hey, let's dump millions into new prisons while we still use 20-year-old tech at schools, right? My window. Let's say I were to go further. When were y'all born? Ow. So let's say that the whole lot of you live a long, healthy, well-supported life. Mass disabling event, no, probably not going to happen. Let's go out to the year, what, 2105? Say you all hit 100. Okay, so I would need to go out to at least 205 on here, right? So you can make this window go further out. Maybe I'll just do 250 for easy's sake. And then try the graph again. Did y'all see at the end of the graph how they started coming apart? They were really good models inside the data, but once we got past the data, look at what started happening. It was like split ends. Yes, I do know what those are. Okay. Look at what happens to that cubic. Okay. And we're talking about median age of a population. Oh. Do you see where, if you were to extrapolate past the data, I would not choose that quartic? Because that quartic, if I had to extrapolate out to here, out to the year 2250 or 2150, if I had to extrapolate out to that year, it says everyone dead. But then honestly, like, we've had the capacity to destroy humanity and sterilize the planet for 70 years now. So maybe. It's not a reasonable model. Nuclear weapons. No, Isabella's over here like, what? No, the nuclear arms race of the Cold War. Like, that, we have had the ability to sterilize the planet since then. Back to this. Just please have it written down, if you can't get that through your head, that if I am inside my data set, interpolation, I choose what has the best fit. But if I go outside my data, extrapolation, then you have to take this into effect. You got to pick which is the best in context. If I had to extrapolate past 2080, I am not choosing that cubic. I am not choosing that quartic. I'm going to go with the quadratic. Okay? Because it's a combination of best fit with reasonable context. And you got to make a judgment call. In fact, this is what a lot of statistics is about. It's you use the numbers. Numbers don't lie. People lie with numbers. You're going to use that statistics. You're going to use your judgment to decide which one is the best. So, I'm just going to go past it. Oh, no, you know what? We are going to use this space, though. This space, right under this. We're not going to do this. But we're going to use this space because we're going to do a little side quest. We will. We're going to do basic arithmetic. Ready? Okay. Lori wants to do basic arithmetic. No calculators. No calculators. Basic arithmetic. You've seen this song and dance before.
Oh no. Oh, it's timesing. Okay. Timesing. Oh, I love doing this.
Go!
Wait, five or like the extra?
In this space, I want you to do that with none, zero calculator.
I did it. Wait, shut up.
Dang it.
I'm adding.
Okay. So y'all coming out of algebra 2, you know where this is headed. Okay. The idea behind it is, if I take 2 by 2 is 4, 2 by 2 is 2 is 6 is 4 is 2 is 4, then what? I'm not now taking 2 times this stuff, I'm taking 20 times this stuff. So you have a 0 as a placeholder to ensure that you're over in the 10 spot to start with. And then 4, 2, 6, 4, 2, 4. And then I'm not taking 1 times this stuff. I'm taking 100 times this stuff. So I put zeros as placeholders and 2, 1, 3, 2, 1, 2. Then what? Okay. The reason that I can add them all up is because, what place value is this in? 10 to the 0 power is 1, right? Anything to the 0 power is 1. What place value is this in? 10 to the 2nd, 10 to the 3rd, 10 to the 4th, 10 to the 5th, right? That is because you have, don't put letters with it, because you have been doing basic distribution of polynomials since elementary school. This, oh yeah, you have, is 2x to the 5th plus 1x to the 4th plus 2x to the 3rd plus 3x squared plus 1x plus 2 times 1x squared plus 2x plus 2. You have been doing this since elementary school. Do you see the place values line up with the descending order of a polynomial? So, check this out. All of that is still true. The only difference is 2 times 2 is 4, 2 times x is 2x. Is 6x squared? Is 4x cubed? Is x to the 4th? Is x to the 5th? Is x to the 5th? X to the 4th, x to the 4th, x to the 3rd, x to the 3rd, x squared, x, constant, x to the 6th, x to the 6th, x to the 7th. You have been doing this entire thing. Okay? Now, here's the only difference. When we're doing regular digit multiplication, I'm able to say 6 plus 4 plus 1 is 11, and every time I hit 10 things, I go into the next place value. That's because my base is 10. I got variables here. I don't know what x is worth. So I can't regroup into the next place value. I just combine like terms. I would call it 11x cubed. I would call it 10x squared, and so on. This is why we show you different ways of multiplication. When you multiply these, if I told you to distribute these two things, how many of you would take this in front of this and you would spaghetti monster the crap out of that thing, showing all of those arrows, and then probably write it in one big long chain, and then have to find all your like terms? Gross. We have different things, right? We got box method, we have a stack method, we have, like, there's all these different ways to organize our multiplication of polynomials, which are the same ways that they are teaching it, or some of you should have been taught in elementary school. Were you ever taught that in elementary school? What if I said 123 times 23? Were any of you taught in elementary school to say 123 times 23? 1 times 2, 2 times 2, 3 times 2, 3 times 1, 6, 9, and then your diagonals are like terms. This is the tens place value. So I put one more down here. This is my hundreds place value. This is my thousands place value. Okay? Because it's done the exact same way. Come on. Everyone's just like, no, you're changing the way math works. Stop it. Because this is no different than x squared 2x plus 3 2x plus 3. What if I called this x squared plus 2x plus 3 times 2x plus 3? Now you have the variable with it, and the variables are like terms, so you can see that they go together. But they will be on the diagonals. Okay? This is just different ways to distribute. I'm saying however you learn to multiply in elementary school, it also works for polynomials. Whatever method you learned. Which means it also works for division.
Oh, I like it. Are we dividing now?
Go!
I need room.
Wait, why did I do this survey? My teacher taught me a different way, and then I never learned the long division way. So I did it once, and then she taught us the other way.
Now, whatever way you learned for the long division, all you got to do is throw variables with it, and it's still going to work for polynomials. It should. Excuse you?
The remainder.
Excuse you? We go to Fraction Town in this house.
How would you do that this way?
Okay.
We're doing really good this morning, so I was hoping we could.
I've got review 7.
And she has the review and has it done.
Which one is this? Colored hair or not colored hair? Okay.
So color?
Yeah.
Rachel, how
Well,
does
she always does the stripes and stuff. It looks good. Okay. Review 6. Quiz 6. In the basket, I gotta sort everything later. Why do I not? No, it's. If she's working, I want her to keep working. Oh! That's right, I had it as a different color. That's why. There you go.
Thank you so much.
Yep, yep. Okay. So, the process is divide, multiply, subtract, drop, start over. Okay? Now, 3 is not divisible by 5. So you go to the next digit, group them together, say 35 divided by 5. Write it, multiply. 7 times 5 is 35. Subtract them. Drop it, it's a little warm. Start over. 2 divided by 5. Nope. 0 times 5, 0. Subtract is still 2. Drop it, it's a little hot. And say, start over. 29 divided by 5. Ah. No, 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 no. I made a noise and was reaching for it already. No, that does not count. I am tired. Be nice.
We can do half.
So 5 times 5 is 25. I subtract, I get 4. Drop it, it's a little hot, and start over. And, all right, Rachel, time to argue.
Okay, but do you ever remember like going to 6th grade, like here's how you divide, you put the decimal, you break it down.
And then,
I don't care, I can't do fractions. You put the decimal, and then you get the 10, and then you get the 2, and there's a point 2. This is technically when
okay, now, include a lot of profanity with this. This is what happened when Caitlin went off last semester. Yes, we put decimal if we want to keep going. I will get 15, or sorry, 10, and then I'll get a 0.2, and then a 0.2 is a 1/5, right? Now, okay, but we're not going to do that because we're not in 3rd grade anymore. Maybe you remember this. That is also ugly. Because I have a remainder of 1 out of 5. When I go to decimal town, don't I get a 0.2? And a 0.2 as a fraction is 1/5. It's this with 1/5 left over. Remainder over divisor. We're not, because we're about to say x plus x squared plus x cubed plus. We're about to start doing that. Okay? So, which is why we go through all the basic arithmetic stuff, hopefully jog some memory here. Because, yeah, the video is just going to be like unintelligible, garbled, screaming noises and static. So,
What did you just say, Lauren? It's not quite. I just realized. No, like as a whole, like to record it's so quiet. Yeah. Whoa. So much fun.
In Algebra 2, you learned we will do synthetic, but you do need both. Maybe. Y'all, if you remember, there is long and synthetic division for polynomials. But synthetic division only works when you are dividing by a linear factor. There is synthetic division for higher order polynomials, but it's gross. I have before just created an algorithm for, it's kind of a bastardized hybrid between synthetic and long division, and it works. But I've never seen it in textbook because I made it. So I stopped showing kids because you'll never see it again. We need to know both methods because both methods will be used because we are going to start dividing by things much bigger than just a linear factor. So, starting with our process. Remember, it's divide, multiply, subtract, drop, start over. That is long division. Okay. Step one, I'm going to take the first term divided by the first term. 6x cubed divided by x. No. 6x cubed divided by x. 6x squared. So where do I write it? Above 6x squared because that's its place value. Okay. Next step. Multiply. Take 6x squared times this entire divisor. Okay? If the entire, okay, vocab check. What's this called? Dividend and the divisor. We did all this last semester. Okay. All right, bring it back. If the dividend and the divisor have a greatest common factor, absolutely take it out of there and make life easier. Yes. In this one, they don't. I would divide this by it, I'd divide this by it, and then say it was divisible by 2. Then I would have that, and then whatever I'm about to get. Okay? As we're going to see as we move through the next couple sections, you don't leave your kid brother at Burger King. If you take 2 out of everything, it's off to the side. Remember it's there. Okay? So 6x squared times stuff. 6x cubed minus 18x squared. What is the next step? I did this. Right?
Great job, teacher.
Okay. Then, next step. Okay. In my experience, I know that the textbooks write it like this. Subtract the thing. But in my experience, kids will subtract this thing and completely forget to subtract this one, getting the wrong sign. So the way that I do it instead is change the signs, right? Because subtracting the thing is adding a negative. Adding a negative is I change the signs and then combine like terms. So 6x cubed divided, or minus 6x cubed, gone. Negative 25x squared plus 18x squared is negative 7x squared. Next step, drop it like it's hot. And then, next step, start over. Now I'm taking 7x squared divided by x. What?
Shut up.
Because it's this whole binomial divided by this whole binomial. The thing that matters, just like when we had rational expressions, is the degrees of the leading terms, regardless of whatever else is after them. It's just like if I try to take something that is in the hundreds and divide it by something that is in the thousands, it's not going to go in, right? But if I take something in the hundreds and divide it by something in the tens, it will go in. So I'm only looking at the leading terms because the degrees of the leading terms are what matter. No, okay. Again, negative 7x squared divided by x. Negative 7x, and look at where I write it. Above the x term. Then multiply negative 7x times this stuff. Negative 7x squared plus 21x. I'm not going to write the plus because I'm about to change the signs. So I change the signs. I now combine those like terms, getting bye-bye and negative 3x. And then I drop it like it's hot. And now that I'm here, start over, go again. Negative 3x divided by x is negative 3. On to multiply. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. I change the signs and subtract. And another reason why I didn't want to go into decimal town is because I don't want to keep going even if this does have a remainder, because my remainder is going to be my fraction, my rational remainder at the end. Okay? So, long division steps. Everything is going to be nice and stacked by polynomial order. See? I have literally had kids do this on larger, like 4x4 graph paper, just to keep everything lined up, if that's your jam. Okay? 4x4 graph paper means there's 4 boxes within an inch. A square inch has 4 boxes in each direction. So, let's do both. Both for reasons. Both for reasons.
It's not going to fill on the page.
And then you get -2.
I actually do want you to stop after you do part A, so we could talk about part B before you do it. Okay. So when you get 1A done, it's okay. It's just I want to talk about something here.
Wait, he gave me a pencil holder. That's so cute. Oh. Like a cow. Oh.
Oh, I didn't.
Okay. Y'all, what's 216 divided by 3?
Like 72.
92. I didn't actually do it.
I did it.
So, if 216 divided by 3 equals 72, 3 times 72 is 216, right? We just said this polynomial divided by x plus 6 is this quadratic. What should now happen?
If you multiply it back.
I should be able to say x cubed plus 7x squared plus 4x minus 12 times x plus 6, and I should get the polynomial I started with. Oh, other way around. Other way around. X squared plus x minus 12. There we go.
It's 2, not 12.
Now it is. See, Goblin 2 helps make the brownies, and that's why my wife likes baking, is because she just is at the counter and he's like gobbling down, hum, 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 all of the like beaters and stuff. Wonder if he just doesn't let us sleep so that she'll bake more. That's devious. But as you multiply through this, you get negative 12, 6x, 6x squared. 0 as placeholder. Negative 2x, x squared, and x cubed. Look at what happens when you add them together. Okay? I'm saying that before you do 3b. Now do 3b. Keep that in mind.
There's a yellow line.
No.
Oh no. There we go. We need two other classes, Lori. I will text your mother, so.
No. You told her too much. She still gets on me about the blind spot.
Because they are real.
Believe it or not.
I'm never driving this car. Or I'm never riding
You
this
can
car.
check the blind spot.
I can't see the blind spot because I'm in the passenger seat.
Oh, well, that's
I mean,
my
I can
problem.
see the passenger side.
Looks like neither of us will be checking.
That makes sense.
Okay. Isabella asked a very good question. Said, if they have a greatest common factor, can I just take that out? Can I? Yes. But don't forget your kid brother at Burger King. I would like you to multiply together 2x minus 4 with 3x squared plus 5x plus 2. Versus, I would like you to multiply together x minus 2 with 3x squared plus 5x plus 2. Do you see the problem? Okay. The problem is that, yes, I will get the same dividend, the same end result, or sorry, the same quotient. Ugh. I'm going to get the same answer. But if you forgot your kid brother at Burger King, you are not going to get the same result when you multiply them all back together. And that leads into the factors and stuff that we're going to do later, where when we do long division, you have to be careful about how you set them up in synthetic division. Okay? You may remember in synthetic division, there's a trick where if it was 2x minus 4, yeah, the thing I'm dividing by is going to be a positive 2. But since I divided that by 2 to create the 0, I would also need to divide my answer by 2, or I would need to put my 2 as a factor out in front of it. Be careful because of that. All right. Polynomial division. I know that this has a bunch of math gibberish on it, but use what you know and the terminology you know. Can you read that? No. Give you a hint. The very first thing is a function divided by a divisor equals. A polynomial function divided by a divisor equals what? A quotient function plus a remainder over the divisor. Okay? And because I was able to do that, that means if I take the divisor times the quotient and add on that remainder, I'll get right back to my polynomial. We say this because now we're going to have remainders. Okay? Divide these. First, set up the problem. Now, for the number of you who have had a job, boy, wouldn't that suck if at the end of those 2 weeks you get your check and you were expecting 302, and instead it said 32. Turns out that 0 as a placeholder is kind of important, right? Hopefully you remember this from Algebra 2. You do need a 0 as a placeholder. You do need a 0 as a placeholder, just like if I was taking the number 9013 and I was dividing by 2, you wouldn't say 913 divided by 2, would you? Same thing. It's just the simplified version of the polynomial may not have that term shown. You have to remember, like big warning neon sign, you have to remember zeros as placeholders. And then on down the rabbit hole. 9x cubed divided by 3x. 3x squared, multiply. 9x cubed plus 6x squared. Change your signs. Negative 6x squared, drop that negative x, a little hot. Start over. Negative 6x squared divided by 3x. Negative 2x. Distribute. Change your signs. Drop that negative 3, a little warm. Go one more time. 3x divided by 3x is uno. But uno times polynomial is not quite there. When I change my signs, I got a negative 5 at the end. We are not going to put decimal zeros and keep going, because now they're polynomials instead of regular numbers. We're also not going to do remainder 5 because we're big kids. Just like I put 1 over 5 was 1/5, I am now going to put plus a negative 5 over 3x plus 2. Or, if you choose, minus 5 over 3x plus 2. They're the same thing. Okay? So now we're going to end up getting remainders. All it means is at the end of it, you stack that remainder on top of the divisor. Not quite. That's where we'll pick up on Tuesday. Because Monday's a quiz. We've just done 5 days straight. Monday is our review and quiz. No, we didn't. We had it on Friday last week.
I just finished my quiz like yesterday.
That's your fault. Y'all, the idea is to not have giant unit tests. It's just every 6th day we're going to have a review and quiz in class. Okay? I just started doing that in the last 3 years, maybe? Before that, it was, we would finish the chapter. We'd be mathing for 2-3 weeks straight, and then, all right, now take a 90-minute test. Go.
You gonna take this stuff now tonight?
I will try.
I don't think we should do.
Put it on the pile. I will try right now.
Okay. I don't think we should do these tests on Tuesday because the quiz is our check.